Welcome to Future Constructs, the podcast exploring the materials and technologies that are literally building our future. I'm Alex.
And I'm Robert.
Today we have a topic that feels like it's been pulled from the past to solve a very modern crisis. We're talking about cement. Now, before you switch off, this is not the gray stuff you see on every construction site.
Okay.
This is a complete reinvention of it. We're diving into a technology from a company called Cercrete Global Solutions, or CGS.
Right.
And they've developed what they claim is the world's first zero-emission ceramic cement.
That is a monumental claim, Alex. For context, producing traditional Portland cement is an environmental nightmare. It accounts for about 8% of global CO2 emissions, so a zero-emission alternative isn't just an improvement.
Yeah, it's a revolution. So what exactly is this ceramic cement?
Well, that's what's so fascinating. It's based on an ancient formula. Ever wonder why Roman aqueducts or even the pyramids are still standing after millennia while our modern bridges start to crumble after just 50 years?
See, they used a different kind of binder. CGS has revived and perfected this ancient chemistry. It uses magnesium oxide and other inorganic minerals, so it's fundamentally different from the limestone-based Portland cement we use today.
So how does that difference play out in the real world? Why do our modern structures fail so relatively quickly?
Think of traditional concrete as a very, very hard sponge. Over time, it inevitably absorbs water, air, and in coastal areas, corrosive salts. Right. This whole cocktail seeps in and reaches the steel rebar inside, causing it to rust, expand, and eventually crack the concrete from within.
Wow, it's a built-in self-destruct mechanism, a slow but guaranteed failure.
So how does Cercrete sidestep that problem?
Well, it's not a sponge. Okay. It's more like a solid piece of granite. At the microscopic level, it forms this dense crystalline structure that is completely impermeable. It's waterproof. It doesn't let in air or salt. The company claims it doesn't crack because it doesn't expand or contract with temperature changes. It's a sealed system.
That's a huge deal for longevity. But what about its other properties? Does it hold up in other ways?
Oh yeah. Does it hold up?
Okay, really?
It more than holds up. It excels. It's said to be 3 times stronger than traditional cement. It's fire resistant to over 2,000 degrees Fahrenheit. And it's even resistant to bullets, blasts, and radiation. But for me, the most stunning feature is its relationship with salt. You mean its resistance to it?
More than that, you can actually mix Cercrete with salt water and sea sand to make it.
Wait, really?
That's unheard of. With normal cement,
That would be like adding poison to the mixture. It guarantees rapid corrosion and failure.
exactly. But with Cercrete, it's not an issue. This opens up incredible possibilities for marine construction. I imagine building seawalls or port foundations using the very water and sand that are right there on site, creating structures that are immune to the corrosive environment.
That's a game changer. It takes one of construction's biggest weaknesses and neutralizes it,
But this sounds like a super material.
right?
It must be incredibly expensive and difficult to work with, right?
Well, that's the other side of their innovation. CGS claims they've engineered it to be affordable and user-friendly.
Okay.
It doesn't require a whole new set of construction equipment. It can be poured, pumped, or sprayed with the same gear used for ordinary concrete. They're not aiming to replace every bag of cement in the world, but to offer a superior solution for critical applications.
And I read that one of its most powerful applications is in repairing old concrete. It says that a Cercrete repair makes the original structure even stronger.
Yeah.
How is that possible?
Well, it's because of its unique bonding properties. It forms a chemical bond with the old concrete. And because it's so stable and doesn't shrink or expand with temperature changes, it becomes a seamless, integral part of the structure. It's not a patch, it's an upgrade. The weak point you just repaired becomes the strongest part of the entire structure.
So we could be looking at a future where we don't just maintain our crumbling infrastructure.
Right.
We actively reinforce it and extend its life for another century.
That's the vision. And it goes even farther. The technology was initially explored at Argonne National Laboratory for containing nuclear waste. Its ability to shield radiation and its incredible stability make it perfect for hazardous environments. It's been used in everything from hurricane-resistant housing to various construction applications. And here's something important to clarify. While this technology has been tested extensively at Washington University in Missouri and other institutions, including hurricane testing, where they shot it 2x4 at the panels from a cannon, and the panels passed a 200-mile-per-hour test for wind force, we should note that we did not do any military runway repairs specifically.
This is a material that truly seems to address some of the biggest challenges we face: decaying infrastructure, climate change, and the need for more resilient and sustainable building.
It feels both ancient in its wisdom and incredibly futuristic in its potential.
It's a compelling blend, isn't it? Taking a lesson from our ancestors to build a cleaner, stronger, and more enduring future.
Now, here's a question we'd like you to think about. If we could build structures that last for centuries instead of decades, how would that change the way we design our cities and think about the permanence of our world?